Hey, we have here another interesting integral today. We've got the integral from 1 over square root of 3 to square root of 3, ln x over 1 plus x squared dx. Okay, it looks like maybe a case for integration by parts. Maybe we could integrate this pretty easily and differentiate ln x, and that's not a bad idea, I think. The thing I really want to notice though is the fact that we have square root of 3 here, and this is just the reciprocal. Okay, this is just 1 over square root of 3. So that's making me think it might be easier if I do a u substitution, like u equals 1 over x. Then we could solve for x as 1 over u. I'll take my dx, and that's just going to be minus 1 over u squared du. And let's see what happens when I do this. So we'll make the substitution, and it's going to just flip the balance, because now we've got 1 over square root of 3 here, and we have square root of 3 here. Natural log 1 over u. Then our denominator is going to become 1 plus 1 over u squared. We'll have this dx value minus 1 over u squared. Well, I can take this minus sign, bring it out front, and I can use this to flip my balance right here. So we'll just swap them, and now we're back to having square root of 3 there. So now my bounds look like our original integral. And then I'm just going to distribute this u squared in here, and let's see what we have. So multiplying u squared in here, we're going to have just u squared. U squared times 1 over u squared is just going to be plus 1 du. And from here, what I'm going to do, let's go back to our original integral, and we'll call this I. And what I want to do is I want something to add to this. You'll notice that we have the same, you'll notice now that we have the same bounds and basically the same denominator, we can almost add these together, but I just need to do a variable change. So let me just change this back to x, and then we'll add these together. Okay, so now that everything's back to x, I'm going to also call this integral I. So I want to add this one to this one, and I'm going to call this 2I. So let's see how we have. Now that we're back in x, we've added these two together, and again, we have two copies of the integral. And what I want to focus on is the natural log situation over here. Let's just focus on this and see if we can simplify it. So if we have ln x plus ln 1 over x, we could do this two ways actually. We could break this one up as ln 1 minus ln x. So by log properties, we can multiply them together. We'll have ln x times 1 over x, but that's actually the same thing as ln of 1, and that's actually the same thing as 0. So what happens here is the numerator is 0, but if the numerator is 0, the whole integral is 0. And we could divide by 2 here because we have two copies of the integral, but 0 divided by 2 is still 0. So for our solution this one, it's just going to be 0. I thought it was kind of interesting because if you look at a graph of this 1 over square root of 3 to square root of 3, it's kind of, I don't know, real rough. It's kind of this shape. So it has positive area here, but it has negative area that offsets it. So looking at a graph, you don't necessarily think it's 0, but it actually works out to 0. So anyway, I thought that one was pretty fun. So we'll stop it there. Thanks everyone for watching today. Have a great day.